365 days, 0 hours, 0 minutes. These would be the numbers appearing on every screen on the planet in bright red against a black background, like a relentless countdown timer. An asteroid larger than Mount Everest, traveling at 30 kilometers per second, would be heading towards Earth. A direct impact would be equivalent to 100 million Hiroshima bombs exploding at once, causing more than a full decade of darkness on Earth. Can you imagine such a scenario? A threat to humanity coming from space with a set date and time to hit us? In this video, we'll explore the options we would have considering our current technology in an attempt to prevent an event capable of causing mass extinctions on planet Earth. In the first few days after the asteroid's discovery, astronomers would check and recheck their calculations, seeking to confirm the probability of a collision with our planet. The simulations would reveal apocalyptic scenarios, firestorms capable of devastating entire countries, tsunamis taller than skyscrapers, and enough dust to cut daylight in half. Agriculture? It would be destroyed. Livestock? Extinct. Life as we know it wouldn't stand a chance. And everyone would remember a precedent. 66 million years ago, the Chicxulub impact ended the story of 75% of Earth's species, including the dinosaurs. The difference is that, this time, we would have science, rockets, and maybe a plan. The first hope goes by the name of Kinetic Impactors. Imagine a cosmic billiard table. In 2022, NASA's DART mission already showed that it's possible to alter an asteroid's trajectory. A small spacecraft the size of a piano collided with the moonlet Dimorphos and shortened its orbit by 32 minutes. Now the idea would be to scale up this technology, sending multiple impactors, each with the force of a grand piano traveling at 15 kilometers per second, all hitting the same spot on the colossal rock. The result would be a sideways push of a few Earth radii, perhaps enough to divert the asteroid threatening us. However, the schedule would be tight: manufacturing, launch, interception, all within a maximum of 8 months. But the engineering already exists, stored on servers, ready to be accessed. If that fails, there's still the nuclear option. A high-yield warhead could be detonated just 100 meters from the asteroid's surface. The explosion vaporizes a layer of rock and creates a thrust like an improvised engine. The calculations from Los Alamos are clear. Done correctly, this method could alter the course of a rock hundreds of meters wide by thousands of kilometers. The problem? Politics. International treaties prohibit nuclear weapons in space. But when faced with the choice between breaking the planet or breaking a piece of paper, the answer seems obvious. There are also more delicate ideas, like the gravity tractor. Imagine a 20-ton spacecraft flying alongside the asteroid, gently pulling it with its gravity. It's an elegant method, but far too slow. It would take years to have an effect, not months. The same goes for ion beams, laser ablation, and solar sails. They all work well in preparedness exercises, but not when the clock is already counting down to extinction. Still, these technologies could serve as a fine-tuning mechanism after a major impact, refining the trajectory in the final moments of the crisis. Now, let's imagine what the most important countdown in human history would look like. Day 1. Leaders of the major nations announce an unprecedented operation live on air. Blank checks, torn-up treaties, bureaucracies dismantled. Around day 30, companies like SpaceX and ULA would already be producing rockets at a frantic pace. Around day 120, the first impactor would need to lift off aboard one of these rockets. Others would follow, launched in sequence like planes from a busy airport. By day 270, a ship with a nuclear warhead would need to be on standby in high orbit as a trump card in case the impactors failed. During these days, bars, living rooms, and cell phones would stop following sports and TV series. The only thing that would matter is the telemetry. From then on, all humanity could do is wait and hope for the success of the actions set in motion months before for the greater good of our planet. The scenario discussed in this video makes us wonder if our existing technologies would be enough to save us. Perhaps the most impactful factor in such a situation is the time between detecting a threat from space and the date of its probable impact on our planet. And speaking of threats from space, watch the video featured in the card above, which deals with the largest comet ever identified. Mapping the night sky, done by professionals or even amateur astronomers using large-scale data, like what will be made available by the Vera Rubin Observatory, could be a way to foresee problems like the one proposed in this video as early as possible. It's a fact that there are countless rocks orbiting the Sun, most of them unknown to us. Therefore, the question to be asked is not if we risk devastating impacts on our planet, but rather if we will be prepared to prevent them or at least minimize their effects. Did you enjoy this journey to defend our planet? Then subscribe to the channel and activate notifications so you don't miss the next chapters. Leave your opinions in the comments. We'll see you in the next Mysteries of the Universe.